Hello everyone. Today we will discuss a derivative of a function in parametric forms. Before that, we must know what is the parametric forms. Sometimes what happens, the two variables are not directly linked, they linked with the help of some third variables, and that third variable is called parameter. Let us have an example. As we know that the standard equation of a parabola is y square equals to 4ax. Okay, as you know that this is the standard equation of parabola. And its parametric equation is, here we will take x equals to at square and y equals to 2at. Here it is parametric form. The parabola is in parametric form. Here the x and y are related with the help of third variable, that is t. Here t is parameter. So today we will learn how to find out the derivative of such functions which are given in the parametric forms. So for that, let us assume, let x is a function of t and y is another variable which is also a function of t. So to find d dx of y, how? Let us consider d dt of y. Now using the chain rule, I can write d dx of y into d dt of x using chain rule. So here, chain rule. Now I will send this upon this. So d dx of y can be written as d dt of y upon d dt of x. This is the way in which we will find the d dx of y when the function is given in a parametric form. Here we can also write this d dx of y, d dt of y is nothing but g dash t, means derivative of this function with respect to t, and d dt of x is nothing but f dash t. Here we must have a condition that f dash t must not equals to 0, otherwise it will be not defined. So let us go to understand this process of finding the d dx of y or derivative by the help of examples. We have to find out d dx of y, and the function is given in a parametric form. Here the x is given, x equals to at square, which is the function of t, and y is given 2at, which is also a function of t. Now solution, we have to find d dx of y. So that can be written as dt d dx of dt. So considering this, x equals to at square, differentiating it with respect to t, so d dt of x equals to d dt. Since a is a constant and this is the 2t, so d dt of x is d dt of x equals to 2at. Let it be equation 1. Now for The second one, y is given 280, differentiating it with respect to t. So d dt of y equals to d dt of 280. d dt of y is 2a is constant and the derivative of t is 1. So it will be 2a. This is now using 1 and 2 and star. Now d dx of y equals to this one, d dt of y upon d dt of x, and d dt of y is what? 2a, and d dt of x is what? 2a t. So 2a 2a cancel, so this will be 1 upon t. This is the way we will find the d dx of y when the function is given in a parametric form. Let us consider another example. Okay, here is another example. Find d dx of y when x is a sec theta and y is b tan theta. If you remember, this is the parametric form of the hyperbola in this way. So to find d dx of y, we have to find, no, here we will take, here the parameter is theta. So d theta d theta of x. Okay, here since x equals to a sec theta, so differentiating it with respect to theta, so d theta of x equals to a is constant with respect to d theta. So directly I am going to write a, the derivative of sec theta is sec theta tan theta. Okay, this one is first. Now for the second, y equals to b tan theta. So differentiating it with respect to theta. So d theta of y b tan theta with respect to d theta. So from here d theta of y equals to b, the derivative of tan theta is sec square theta. So this is equation 2. Now using 1 and 2, we can have d dx of y equals to d theta of y upon d theta of x. So d theta of y is b sec square theta and d theta of x is this one, a sec theta tan theta, a sec theta tan theta. From here we can cancel one sec theta to this, so d dx of y is b sec theta upon a tan theta. One thing we can change it into sine and cos, b 1 upon cos theta whole upon a sine theta upon cos theta. So from here cos theta will be cancelled and this 1 upon sine theta will be cosec theta. So finally we will get answer b by a cosec theta. Okay, let us have one more example which is not in the form of parametric, but in this example we will use the way of parametric form. We will assume a parameter and change the given equation and then we will solve it. Let us see how it's become easy. Let us have an example. in this question it is asked that find d dx of y, but the given function is not in a parametric form. Okay, it is implicit or explicit form. You can do in a finding the derivative of implicit functions or finding the derivative of explicit function. Here we can use the finding derivative of by the implicit function, but here I am going to apply the parametric form. So for that, first we have to change it into the parameter. For that, let us assume solution. Here given x power 2 by 3 plus y to the power 2 by 3 equals to a to the power 2 by 3. Let x equals to a cos cube theta, where theta is a parameter, and y equals to a sine cube theta. Okay, so why I have assumed this by own? Let us see whether these satisfy the given equation or not. So to check it, note I am going to put in LHS. Here x, in place of x I am going to put this a cos cube theta whole power 2 by 3 plus a sine cube theta whole power 2 by 3. You will see this a power 2 by 3 and cos theta whole power 3 into 2 by 3 plus a power 2 by 3 into sine theta whole power 2 by 3 into 2 by 3. You can see 3 cancel. So from here, taking common 2 by 3, a to the power 2 by 3, here we will get cos square theta plus sine square theta. So we will get cos square theta plus sine square theta is 1. So in that place we will get this, or a to the power 2 by 3. So which is RHS. So we can take this where theta is parameter. Okay, now I am going to find the dy by dx. For that, x is given a cos cube theta, so differentiating it with respect to theta, so d theta of x equals to a cos cube theta with respect to d. I am directly going to find the derivative of this using chain rule. Actually the answer will be 3a cos square theta, and the derivative of cos theta is minus sin theta, so I am putting minus sin theta here. So d theta. Now for this second one, y equals to what is a sine cube theta, so differentiating it with respect to theta, so d theta of y equals to a d of sine cube theta. Again I am going to do it directly using chain rule. I can write a 3, so 3a sine square theta into the derivative of sine theta is cos theta, so d theta of y is this one. Now using the relation we can find dy by dx. Now d dx of y can be written as d theta of y d theta of x. So d theta of y is this 3a sine square theta cos theta upon d theta of x is this minus 3a cos square theta into sine theta. Now 3a cancel, 1 sine theta will cancel from here, 1 cos theta will cancel. So this will be minus tan theta. Or you can just write it minus sine theta upon cos theta. If you remember, we have taken x equals to a cos cube theta and y equals to a sine cube theta. So from here, if we are interested to find out cos theta, so cos theta will be what? Cube root of x by a. Similarly, from here, sine theta will be cube root of y by a. So I can put here d dx of y minus sine theta cube root of y by a upon cube root of x by a. Or I can write cube root of y by a upon x by a cancel. So finally we get answer. This is cube root y by x. You try it in the way of implicit function, you will get some a little bit tedious than this method. So we can use the method of parametric form even the function is not given in a parametric form. So thanks.